Assalamu alaikum. Welcome to my channel Tech Talk with Shahid. Today's topic is how to calculate bolts for a pinned connection. Pinned connection, as we discussed in our last vlog, pinned connection we used when we don't need a rigid connection and just we need to support our lateral forces, not movements. So in that location, we use pinned connections. We will draw one connection, then we will see how to calculate bolts for any project. Suppose this is our steel column and it's our fin plate, and this is our beam, or we can say rafter. So this fin plate is connected with welded connection with this column flange. This beam connected with this fin plate with 3 bolts. So bolts for steel connections, always we use grade 8.8 bolts, and this is our fin plate. And suppose we consider these bolts 3M20 bolts, grade 8.8. We will put some forces for our easy calculation. Suppose this is our horizontal shear or axial force. We can consider this as 50 kilonewton, and this is our vertical force, which can be Fy, or we can say like shear force. This also we can put some value 100 kilonewton. So this is our forces and these are our connection arrangements, and we know this we are using 3M20 bolts and plate thickness. Fin plate we will calculate in our next vlog. First we need to see whatever is our assumption, like we consider 3M20 bolts, either this assumption is correct or not. Just we will calculate this only. First we will see, this we can say this is our Fx and it's our Fy. First we will see from our Fx forces or axial forces how much contribution comes for bolts, like Fx is equal to, it's our 50 kilonewton, and divided by number of bolts. These are 3, so here it will be 50 divided by 3, 16.67 kilonewton. What it means? 16.6, and suppose this is our one bolt. So this bolt will share this much forces, 16.67 from Fx. Now we need to calculate how much will be per bolt Fy forces. That we will see. This is our Fy and it's 100 divided by 3 is equal to 33.3 kilonewton. So this 33.3 kilonewton, this will be vertical for 33.33 kilonewton, which will be shared by one bolt, because we divided by 3. So now whatever forces we will calculate, we will get it in per bolt form. So on this bolt we have 16.67 in shear in this direction, and 33.33 in this direction. We need to see resultant force. We need to see resultant, because when there will be horizontal shear on this bolt, same time there will be vertical on this bolt, so our resultant will give the combined force, shear force, how much will be per bolt. How we will calculate this combined shear? We need to see resultant shear. This will be under root fx square plus fy square. So this will be our, we can say, 16.67 square plus 33.3 square is equal to 37.3 kilonewton. This is the shear value which will come on single bolt, either this bolt or this bolt. So every bolt will share this much shear force. So now we get it, our actual shear force, which is 37.3, and now we need to see how much is capacity of, this is the actual force, actual shear force, and now we need to see how much will be capacity of each bolt, each M20 bolt, which we consider for this area. And here we can see for this calculation, for bolt capacity, we need to calculate like this: shear strength multiplied by area of bolt. So whatever is area of bolt, that we need to multiply by shear strength, then we will calculate actual capacity of each bolt. So area, first we will see area of M20. If we will calculate actual area, that will be 3 pi d, that will be pi d square by 4, which will be 314 mm square. But since if you see in bolts where we have a threaded part, and some part is straight, and this is our bolt, our area here, it can be 314, but in threaded part the area of bolt will be much less. So simply what we can do, we need to calculate net area of bolt. That can be 314 multiplied by 0.8, which can be 314 multiplied by 0.8 to 50 mm square. So what we need to do now, our shear strength is equal to 375 MPa for bolts. So 375 multiplied by 250 is equal to 250 into 375 divided by 1000. So 90 divided by 1000 to calculate in kilonewtons. So it will be 93.75 kilonewton shear. Shear capacity of bolt, M20 bolt. So this is our capacity, 93.75, and this one is our actual force. So now 37.3 less than its capacity, which is 93.75. Hence our connection is okay. So like this we can calculate for any type of forces. We can calculate how much bolts we need. This way we can see whatever we consider, either this justifying our connection or not. I hope this calculation is very informative for you guys. If you learn something from our vlogs, we will request to like it, share it, and comment it to our vlogs. So in our future vlogs, we will come with new calculations, new ideas, new techniques. Till that, thank you so much.